Okay, and this is day 8, and it's a quick review of the paper, just to explain, I guess, a few things about the questions to give you a go. If you want more specific videos, then you need to complete the survey, or email me specifically and ask for which question you want done in more detail. Cool, so question 1 is a normal distribution question. It involves algebra. They've told you 2 bits of information. One is that the mean is 5 times standard deviation, and the other is this little fact here, that the probability that it's greater than 20 is 0.0732. So what that involves is, first of all, using this part here to work out the z-score that goes with that. And that would mean you can set up a little equation which for z, but you still won't know what the mean and standard deviation is. But then you've got another equation here which links the mean and standard deviation, so then you can solve it simultaneously to find out what the mean is. Okay, that's quite an algebra question. But you could still pick up at least one of those marks, even if your algebra isn't awesome, in just looking up this value. And when you look up this value, it's not going to be 0.0732, it's going to be 0.9268 on the middle of the table to find your z-score. Cool. For part 2, this is one of those questions involving the formulas for mean and standard deviation. And you've got 2 groups here. You've got the group which is the initial speeds, which is x, and then you've got the transformed variable, which is where you've taken 50 kilometres off each of their speeds. So my advice for you is to set up 2 columns, a column on one side which is x, a column on the other side which is x minus 50. You're still going to use the same formulas for the mean and standard deviation. Just remember that the standard deviation doesn't change whether you take 50 away from the values or not. But obviously the mean will be 50 lower for this group as opposed to the original x group. Okay. For question 3, as a normal distribution question again, aren't you guys lucky? They've told you what the mean and standard deviation is, and they've asked you to work out the probability that it contains less than 440 mils of juice. That's not so bad. Then they've told you that 94%, basically the central 94% of cans are between 2 values, either side of the mean. Okay, so you're going to find the value of C. So I've done a video for this, I think, or a better explanation in one of the other days, but really it just becomes a case of you realising that when they say 94% contained between it, they're actually talking about a centre, an area of 0.94. And on your table at the back, your normal distribution table, when you look up to find z-scores, you actually are looking up a whole shaded area, so like a left tail. You're not looking up a central area. So what you'd have to do instead is look up 0.5 plus half of 0.94, which would be 0.97 is what you'd actually be looking up to find your z-score. For question 4, here he's doing 5 integers, that's n, and they're between 1 and 9, and you want to know the probability that at least 2 of these are less than or equal to 4. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 4/9 of them are going to be less than or equal to 4. So your P is 4/9, and your N is 5, because that's how many trials you're doing, 5. At least 2 would be 2, 3, 4, 5, but it's faster to work out 1 and 0 and then take that away from 1. Okay, and then for part 2, we're going into a situation where we've got a few unknowns here. So I'm just going to move this up for a second. So he's still generating n number of integers between 1 and 9, and you are looking at the probability that some of them are less than or equal to a certain k value. So you don't know what that k value is, but remember before it was 4, so it was 4/9, because obviously 4 out of those 9 digits would be less than or equal to 4. So in this case here, n equals n, in this case, and p is going to equal k over 9. Okay, because there's always 9 integers. We're just not too sure which one we want them to be included. So for part 1 it was less than or equal to 4, so the p-value was 4/9, because there's 4 values that are less than or equal to 4. Let's say k in this case was 3, it would be 3/9, right? If it was 7, it would be 7/9. So that's what we've got so far. So n equals n. That seems redundant, but I'm just trying to set it up for you. And p equals k over 9, what we know is that the mean is n times p for binomial distributions, and the variance for binomial distributions is n times p times 1 minus p. Now we normally put q there, but q is just 1 minus p. So what you can do now is you can set up two simultaneous equations, because you know that the mean has to equal 96 and the variance has to equal 32, and you've got some other relationship things here that you can use to solve those values for n and k. Sorry, solve those equations for n and k. Okay, on to question 5. We've got all this money being spent on clothes, which is very exciting, by 27 people. Yay, for 3 marks, just construct a similar graph for the data. So just remember, similar graphs are all good, but they need a key. Okay, they need to put a little key there explaining how the similar leaf make up each of these numbers here. And don't forget to do that. Find the median and interquartile range. You guys should be sweet with it by now. And then for part 3, they just give us a little rule for this formula. So you take the interquartile range, times it by 1.5, and then add it to the upper quartile. I've seen that rule before, but normally it's 1.5 and then you add to the median. That's weird, but anyway. Okay, so that's fine. Then you just go through and list the outliers, and just make sure when you list the outliers that you do them with dollar signs, because that's what the variable is. So that's not a big deal. For question 6, planting some trees, 12 trees along a main road. It's very exciting. 4 different types of trees. So 4 hibiscus, 9 jacaranda, and 2 oleander trees. They say different selections. Okay, so all they're saying is not placements, not arrangements, but selecting them. Are they in or are they out? And again, they want there to be at least 2 of each type. So what you're going to do is make a list of all the ways you can make at least 2 of each type. That adds to 12. Okay, so for example, you might have 2, well, there's only 2 oleander trees, so you have to have those 2. So you're always going to have the 2 oleanders, so then you're looking at the other 10. So it could be 4 of the hibiscus and 6 of the jacaranda. Or 3 of the hibiscus and 7 of jacaranda, or 2 of the hibiscus and 8 of the jacaranda. So for each of those different ways, you're going to multiply that across and then add up the different ways to get the total number of ways that you can do that. Then for part 2, they're talking about, in part 2 and part 3, they're talking about arrangements. So you are putting them in an order along the road, and they want the hibiscus trees to be next to each other, the jacaranda trees to be next to each other, and the oleander trees have to be next to each other. So you've got 3 groups of trees, so that gives you your 3 factorial, but within each of those groups you can arrange the hibiscus trees 4 factorial ways, the jacaranda trees 6 factorial ways, and the oleander trees 2 factorial ways. So it's going to be all of those different ways multiplied together. And then for part 3, you don't want a hibiscus tree next to another hibiscus tree. So what you're going to do is take the other 8 trees and arrange those 8 factorial ways, and then that leaves you 9 gaps between all these different 8 trees. So when we've got more places than what we have, we change tact, and rather than just using a factorial as it is, we have to think about placing the trees in those gaps. So you've got your 4 hibiscus trees here, and the first hibiscus tree, you've got 9 gaps you can place it into. The next tree, there's 8 gaps left. The next tree, there's 7 gaps left. And the last one, there's 6 gaps left. So it'll be 9 times 8 times 7 times 6. If you multiply that all together, you'll get the total number of ways of arranging those trees to meet this condition here. For question 7, you've got these bags of sweets, chocolates and toffees for Susan, and chocolates and toffees and boiled sweets for Ahmad. And you take 1 from Susan's bag and put it into Ahmad's bag. And then you take 1 from Ahmad's bag. So I think there was a similar question to this somewhere before. And that happens sometimes when you have 3 versions for the same session. They do try to make them similar so that the standard's the same. But you would set up a tree or some sort of diagram to keep track of what's happening. So initially here you've got 7, 8, 9 sweets. But when you take 1 out from here and put it into here, you'll have 10 sweets. And so you'll have to be careful how you do your tree. I'd do a tree which is the first branch would be Susan's bag and the second branch would be Ahmad's bag of sweets. Part 2, it's a conditional probability, so watch out for that. So given that it's taken, so given that the one in Emma's bag was a chocolate, find the probability it was a sweet. From Susan's bag was also chocolate, so you're going to have to use a conditional probability for that. Use your formula. And then for part 3, you're looking at how many number of times a chocolate is taken, and you're drawing up this probability distribution. So you just have to remind yourself a probability distribution means that you're going to have all the possible values across the top, and for each value, the probability that goes with it. And then go through and fill that out.